This video is about misconceptions to do with the volume of a cone, and then we'll move on to surface area. So first thing you need to consider is the formula, which allows us to work out the volume of a cone. So you're given this, but it's just kind of an understand of how it works. I think sometimes it helps with a little picture. So if I just sketch a cone and just mark some of the key points. So the height is the perpendicular height, and the radius, notice, forms a right angle triangle. And the final bit of information we might need later, but not for volume, is the slanted length on the outside there. So the formula, like I said, you were given, so volume equals 1/3 pi r squared h. If we're given this key information, radius is 6 and height is 5. Quite often on the non-calculator paper, you might be asked a question like this and you'd be expected to give it in terms of pi, so you could actually do the sort of working out with the formula and then not necessarily find it, don't use your calculator to find an answer, but find an answer in terms of pi. So let's work through this. So it's always good practice to rewrite the formula, and that means that the volume is 1/3 times pi times the radius squared. So the radius in this question is 6, so I'm going to put that in a bracket just to make sure that we're aware that it's the 6 that gets squared, and then you multiply that by the height, which is 5. So if you work that through, we want 1/3 pi, and then we've got 36 times 5, which comes out as 1/3 pi, and then 180. So what we'll need to do there is, if we divide 180 by 3, that'll leave us with 60 pi, and the units will be centimetres cubed. So linked closely to that is the surface area of a cone. I've brought up two questions here that just kind of show that you need to kind of have a real deep understanding of where this formula comes from, because those questions on the surface look very similar, but there's a quite subtle difference about them. So if we were to draw the net of a cone, I think sometimes having the net of a cone quite helps you understand where this comes from. So if I just draw the net, so this first one, this little shape here, you get the area of that by doing pi r L. Remember, L is the slanted height. And then you've just got a circle after that, which is just pi r squared. So if we look at this first question, it says, which of the following would correctly calculate the surface area of the base of this cone? So very, very sort of careful on the language there. It's only asking for the surface area of the base of the cone, which is the circle. So first thing to notice there is they're actually given the diameter. So it's sometimes useful to just write the radius on there as well. And then we know that we just want the base of the cone, which is just the circle. So obviously the circle area is pi r squared, which would mean that this would calculate the area of the base of the cone. A subtle difference over here, so you've got exactly the same picture, but this time it's actually asking for the curved surface area of the cone. So it's just this little shape here that we mentioned before, and that's pi times radius. Remember, that's 6.3. And then it would want the length as well. So thing to notice there is we don't actually have the length. We've got the perpendicular height over here, and we've got the diameter. So you could work that out using Pythagoras. So draw out the right angle triangle. We know that this is 4.2. This is, I'll just put an X there because it's what we don't know. It's what we would need to work out. And then we've got half of the diameter on the bottom, so you've got the radius, which is 6.3. So you could work out that missing length, but none of these would actually give us the correct answer there. So we would actually need to do a little bit of further work using Pythagoras.